industry mentorship program, also called as CIMP, would definitely provide the required exposure needed to all the students present here. To spread awareness among students of the demanding technologies, skills, and availability of jobs, CIMP will definitely prove to be a helping hand. We would be inviting leaders in industry, such as our chief guest of today's event, Safdar Sir, to provide guidance to the young talent and also to assist them develop the required skills that would help them to make a difference. I cordially invite Ms. Mahina Mahmood, General Secretary of IEEE AMU Student Branch, to give a delightful introduction of our speaker. Mahina.
Thank you so much, Ifra. Assalamu alaikum. Good evening to all of you. This is Mahina Mahmood, jointly serving as the General Secretary to IEEE STB and also as the Chair to the WIE Affinity Group. First of all, I would like to welcome you all to this very first session of the IEEE Career in Industry Mentorship Program, which is newly inaugurated and started by our IEEE STB. So for the very first session, we have invited Mr. Safdar Kazim Haider, Regional Analytics Lead at Uber. Mr. Haider has 9+ years of experience in data science, marketing analytics, big data, consulting, and business development. He has worked extensively on creating machine learning-based predictive models for better targeting of various marketing campaigns. He is currently leading a team which provides analytical solutions for Uber Eats business in AP-AC region. He has done his MBA from IIM Indore in 2013, and also he has his bachelor's degree from AMU in the year 2010. None other than Mr. Haider would have been the best pick for this session on career in data science and analytics. So we are extremely grateful to you for accepting our invitation and to guide and mentor the students here at AMU. We hope to receive your continuous support in the future as well. We are also extremely thankful to Farhan Saeed sir for his continuous support in organizing this event. Thank you so much, sir. Now over to you, Ifra. Thank you.
Thank you so much, Mahina, for such an insightful introduction. I'm very pleased to welcome Mr. Farhan Saeed sir, who is currently serving as the Training and Placement Officer, AMU. I would request sir to say a few words and enlighten us.
Definitely. Thanks a lot, Ifra and Mahina. We would definitely like to cordially invite Safdar Kazim Saab again and thank him for his time. Today, a big thank you to Mr. Mohammad Faizan and your whole team in IEEE who have started and taken the initiative this year. Look, and we thank all the participants who come in overwhelming response. Normally, as I was discussing earlier with Faizan, we do webinars on various topics. And generally, the footfall is, in the range of under 100. And here the response was, overwhelming, twice that number in general. And I think more people would be coming in, I suppose, as we proceed. So, which is great to see. With regards to the topic itself, with regards to big data and analytics, the coming age, as everyone says, this is the age of data and things are happening. In our view, when I graduated like 25 years ago, these things were still there and they were starting out. And a lot of industries were based on big data. And work was happening for a long time. I studied in Melbourne for 3 years. And then we lived there for about 15. And there were actually, you might have heard, a lot of you would know, I'm sure Safdar sir would be very familiar with it. There's a whole branch of study called Actuarial Studies. And they form the foundations of banking and insurance companies. So that work, it's huge and it's everywhere in every part of the world. And they form their, their premiums and their lending rates and all that are based on, what happens out in the industry. So, for example, they would study the cases that have come, for example, under medical work, obs and gynae or any field of medicine, and they would say, okay, these many number of cases we get, this is what we had to pay out, and the premium would be for the doctors to get their insurance would be this year. And that's what, just an example of, working in big data and how you do that. Now, of course, it's boomed, to exponential levels, and pretty much everybody, so much work is happening in terms of logistics. All of, I would say, the spine of all this work would be big data and the work and the analytics of big data, which you guys are obviously into. So without wasting too much time, I would again thank all of you and ask Dr. Safsar Kazim Saab to, get into the details of things, and I'm sure he'll be able to give you, wonderful insights of the current world and what's happening in the industry these days. So I thank all of you again for joining, and we'll be in touch, hopefully. Thank you.
Thank you so much, sir. As rightly said by Oprah Winfrey, a mentor is someone who allows us to see the hope inside yourself. So with that being said, let us call upon Savdar sir to take over. Over to you, sir.
Sure. Thanks everyone, and thanks for this great introduction. What I have done is I've tried to put down a presentation. It's similar to what I presented last year also, but the takeaways are similar. But I would just want to, what I would want to do is to emphasize what all things are necessary for someone to pursue in this field, what people do who are just in the third or fourth year of engineering colleges, what they can do more, what are the options which exist, and what are the areas they should focus on to build a career in data science and analytics. Largely what I've tried to do is I've tried to put down different topics, which I'll just give an overview about, and then you can, at your level, deep dive on those topics, or there could be separate presentations or sessions for each of the topics, because 1 hour doesn't allow to cover everything. I will try to give an overview, and then so that everyone is aware of what are the key points to be aware about, and then they can themselves gain knowledge on those areas. So I'll just start with presenting my screen. Are you able to see the screen?
No, sir. Yes.
Not it? Yeah? It's okay. Let me put in present. Okay, so I will start with my background, how I started to get into this, how I got into this field. I was not a computer engineer. I did my engineering in 2010 from Acumen Electrical, and then from there I joined Accenture. I worked there for a year, and then I got admission from IIM Indore, and then started my post graduation there. After 2 years, I graduated, and then I joined Cognizant Business Consulting as a consultant in 2013. And at that time itself, there was a lot of buzz about big data analytics and all those things. And just to add to it, during my MBA also, I did some of the courses which are closer to statistics, analysis and all. That helped me to make a switch from consulting to analytics. And I moved in 2014, and I joined American Express. So in 2014, I moved to this domain of data science and analytics. And what I used to do at American Express was, most of you would know American Express is a financial services company that provide majorly credit cards offerings. And what we used to do is I was part of marketing data science team that used to identify which customers are the right ones to target different products which American Express had. So there was a whole about a lot of predictive modeling and machine learning which was involved, that whom should we offer what, and based on those recommendations, just to improve the return on investment or the cost, or to make it the process a lot efficient, these models were used to target the right set of customers. And so that I did for 3 years, and in 2017 I got an opportunity to at Amazon, and I joined as a data scientist there. I worked there for a year. I was part of Amazon Business. So like there are two arms if you think about. One is the B2C, which is, for example, if I have to buy something from Amazon, it's through the Amazon.com portal. But if let's say a large business has to buy something, let's say General Electric has to buy something from Amazon, there's something called as AmazonBusiness.com. So I was part of that team based out of Hyderabad, and I worked there for a year. And then in 2018, I got the opportunity at Uber, and since then I have been working for Uber, and I'm leading a team of analytics folks who provide all the like a lot of analytics and data science support for the Asia Pacific region. For the Uber Eats line of business. So like you would be using Swiggy and Zomato in India. Like similarly, there's something called as Uber Eats. Not so they are no more in India, but they are in various parts of the world, and there are various countries in Asia Pacific region also where they are operating, and I work for those markets. So what I wanted to emphasize is that it's just, although like being a computer engineer, it's an added advantage because you're closer to programming. But like despite being from non-computer engineering background, I ended up into this line and then for around 7-8 years I've been part of this. So I really enjoy this domain, and I plan to build my career in future also on similar lines. Like through on the job only, I learned a lot of things, whether it be like different machine learning algorithms, Python, SQL, like how to productionize things and all those things. So this was all on the job learning which I made, and like I'm very always excited about discussing on these kind of topics. So that's on my background. Any questions from anyone? Like keep it. I don't want to keep it very formal. Like I'm happy to have any questions, and even whenever anyone has, and I can address those. So, like I will try to keep it at the end as well, if possible, the time permits, to address the questions. So what I have tried to do in the next few slides is basically I will try to give you an overview on where the industry is headed towards, and what all things different recruiters look for when they are hiring for these folks, and what are good things people in their second, third, and fourth year of engineering currently can do, so that they prepare their resume like that when they go into the market. It's easier for them to crack those discussions and interviews. So that's how I've tried to put the presentation. Like it's quite a booming industry. Like as the data is increasing, the volumes are increasing. There's so much to explore in that database, and the objective is to come up with insights that can help businesses to optimize their cost or grow their revenue, right? And I've just pulled this out from NASSCOM, right? They project that by 2022 it will be a $16 billion industry. Growth rate is around 25%, and India would be like among the top 3 markets providing these kind of services across the globe. So like with the industry being growing, the job opportunity increases more, and then avenues come more, and it becomes easier to, if you have the right fit on your resume, it's easier to crack those kind of jobs because the supply in terms of jobs is higher, right? So like it's quite a like if I tell you like someone would have joined IT 25 years back, right? And like that person would be well placed as of now because they joined just at the start of the boom when the Google and Yahoo and everyone was hiring aggressively just to build themselves up in this technology domain. Now they're trying to hire, by IT I mean software engineering world, but like for last 10 years there have been a lot of ramp up on data science related jobs from these kind of companies, and yeah, I think the trend is still holding strong. Now, anyone can answer what is data science? Just to make it attractive. I don't want to make it a monologue. Yeah. I put it on the slide. Like if anyone can just read through the slide and then I can explain what is data science.
Handling through information.
Sorry, can you come again?
Handling informations.
Okay. Okay.
Using the data we have in a form that we can get a efficient output from it for market.
Got it. Got it.
The interconnection of machine learning, software development, and traditional research.
Got it. Okay. So I think all three of you are right in portions. Like I think if I combine all 3 points, it covers most of it, what data science is about. And that's what this Venn diagram shows. So if you see, there are 3 aspects to it. One circle is showing the understanding of computer science, I think, which Farah mentioned. And then there's understanding of maths and statistics. And the third is the domain and business knowledge. I think the first 2 parts is pretty clear for everyone because everyone is studying that and they are across what each of the topics are. I think I will try to focus more on what domain and business knowledge means here. So computer science, right? Like understanding of like knowing programming, knowing data structures, knowing everything what is being taught as part of computer engineering. Specifically, I would not say like pretty like hardcore programming, but understanding of like programming for machine learning algorithms through Python would be good. And second aspect is like understanding what all machine learning comprises of, right? And I will deep dive more into the next slides, like what all it comprises of. So that's one aspect of it. And then there's maths and statistics, which is very essential, like topics which are covered in applied mathematics in first and second year are what is used here as well. Then there's third aspect, which is domain and business knowledge. So if you think about any software engineer work, right, it is at the intersection of computer science and domain and business knowledge. So what domain and business knowledge is that, for example, I'm working for American Express, right? My domain is financial services. And I should know the credit card industry in and out to come up with something, right? So that is the domain and business knowledge I'm talking about. Similarly, like if I'm working for Amazon, I should know the e-commerce play. What does each feature on the Amazon website? What's the purpose of that? And what the revenue model or the business model of these big organizations is. So that's what domain and business knowledge is. And then third part is maths and statistics, which is, I will cover what all topics are important. And like being strong in maths and statistics helps you in coming up with good estimates, good sizing of the problem. So there it matters a lot. And also it also helps you in doing some analysis, validating different models, you have predictive models you're bringing. Like so yeah, that's why maths and statistics is important. So like if you think I think the TPO sir was also saying actuarial sciences was there, right? So actuarial sciences didn't have that much of computer science aspect to it. It majorly had maths and the domain business knowledge. So that is traditional research, what an economist, what a statistician will do, right? Now there's what software engineer will do. He will work in the intersection of computer science and domain and business knowledge. That he will do coding for, let's say, creating a product feature for a company, right? And for that, he would need some business knowledge. Then there is someone who builds these machine learning algorithms. Like if I think about neural network, right? Someone would have built it, right? There, it's just the intersection of maths and computer science. But the intersection of all three is where the data science sits. That you have to know about computer science, you have to know about maths and statistics, and you have to know about domain and business knowledge. All these three things combined make you a strong data scientist, and that you should aspire to do. So, like when you are planning to have a career in this domain, make sure that you are strong on each of the three aspects. And for each of the three aspects, I have some slides in future that I'll try to explain and what all topics you should be strong based on the current industry. And I don't know where it evolves in 5 years down the line or 4 years down the line, because it's always a changing dynamic. industry. And based on the current as is state, you should be aware of these three topics well. Any questions? Because this is very important. This foundation of the next few slides where I'll be deep diving. Okay. So now coming to the first thing, which is about like what kind of roles which sit in the industry of related to big data, right? Largely, there are four kind of roles. One is a data analyst. Second is a machine learning engineer. Third is the data engineer, and fourth is the data scientist. So and these are the different skill set people look for largely, right? For each of the job roles, the skill set level of expertise in the skill set requirement vary. And if you see, data scientists have like very important marked skills across most of the line items, right? So, for example, a data analyst is someone who just pulls the data via some data aggregation method, whether it's SQL or Tableau, and analyze it and come up with an insight which can be used to drive some business decisions, right? For example, I figure out that these kind of customers don't pay back their money on the credit card, right? So that could be very helpful for the credit card company as a whole, that, okay, these are the customers whom we should do something else so that we recover the money from them. These are the bad customers. So this is a simple data analysis which someone does, pulls the data, do some slicing and dicing, come up with good visualizations and present it to the business teams and saying, okay, this is the segment of customers which is not good for the business. They are loss-making customers and we should handle them differently. So this role requires strong programming language tools, majorly not towards Python, a bit on Python, good to have, but SQL is must. Good visualization tools like Tableau is helpful. Strong communication skills, because these are the folks who work directly with the business teams, right? And these are the folks which are very strong in communication. So you should be able to communicate what the data says, right? So you should have that ability that you present your slides well, create your slides well, so that the story which you are trying to tell to the business teams goes across and you are able to create that impact. Then understanding of data, right? You should have that intuition. Okay, if this is the trend, what does this mean? You should be able to read data well, and lastly, statistics, because it's about slicing and dicing, coming up with averages, percentile distribution, and all. So statistic does matter there. Machine learning engineer, on the other hand, is a person who basically, I'll come to machine learning engineer later. I will first figure out, explain data engineer and data scientist. So data engineer is someone who tries to transform data. So basically, they manage the whole database. They create the whole database for the company, that they get the raw data which the company gets. Let's say Amazon on the platform gets all the data related to what clicks are made by the customer, what their customers are ordering more. So they try to transform it into a way that is more readable, more easily queryable, and they store it into different tables, and they create a whole structure, like whether you want to store it in a distributed environment or what, based on size of size of the data. And the role of this person is that they should be very strong. The role requires you should be very strong in SQL programming tools. You should be strong in software engineering, because you have to run. Yeah, I think Anis is asking, is it suitable for students who don't have coding or CSE background? I think I'm not someone who is from computer science background. I'm in this field only. So I think that answers your question. Okay, so so like data engineer is someone who is good at SQL. SQL is must, and he's very good in data wrangling, because data wrangling means that you are able to convert a raw data into a form which is easily queryable, easily readable, and then finally you are good at software engineering. Data scientist is someone who uses this data which a data engineer prepares and builds ML models, builds using programming methods like languages like Python, R, come up with machine learning algorithms, come up with good visualization of the data so that everyone understand what that model does, what are different insights from the model, and like and then they should be decent on the software engineering aspect as well, because their model gets productionized somewhere. There's a lot of knowledge you need to have around APIs and all. So I think that would also be helpful. So once this model is being built, a machine learning engineer creates it, basically someone who owns the platform that will productionize this model at a larger scale for the company, right? So these models are quite complex and quite resource intensive in terms of in terms of the computation power required, and that it needs a strong infrastructure, IT infrastructure or platform infrastructure to back it up. And that's what machine learning engineer does, that they build that kind of infrastructure that supports those kind of models to run and get productionized. Okay. So these folks are very strong in software engineering. These folks are strong in machine learning, programming, and all those things. And they're technically strong folks, and that's what is required. Any questions on these broadly 4 kind of job roles which are there in the area of big data analytics? Cool. I'll move to the next slide then. So now coming to what I think, if you remember the Venn diagram, right? There were 3 aspects to it. One was the computer and IT aspect, computer knowledge, this programming knowledge. Second was around maths and statistics, and third was around business acumen. So I will try to cover each of the aspects and try to give keywords which would be helpful, and you can go and read about them for getting understanding of these things. I think most of you who are already into these kind of things would be aware, and it would not be new things for those kind of folks. But like for the ones who are not very aware of what all things are being asked in these kind of job roles, I'm happy to walk you through. So one thing was, like, as part of knowledge on computer and IT, there are 2 things. One is, obviously you should be very strong in SQL. That is the bread and butter for us, because you pull the data through SQL only most of the times. And you should know the querying languages. You should know how joins work, how group by work, how ordering works, how partitioning works. So those kind of things you should be pretty strong, and it should be at the commands and the programming language. It's not actually programming; it's querying language. So it should be at your fingertips. Like, what does each of these things mean, and how to write a script for querying that kind of in that kind of way. So ranking, how does ranking works? How does partitioning works? So, like, basically, all in all, what SQL tries to solve for. So, like, just for my understanding, like, anyone from computer engineering, like, who can let me know, like, as part of the curriculum, I hope that these things being this would have been taught, right? I remember, I think when I did my BTech in my first year, when there was C course, I think there was an aspect of SQL as well. Is there anyone from com science?
Yes, sir. I have some idea about SQL because I learned in class 11th and 12th.
Okay. Yeah. So I think good thing is that SQL is a very easy language to pick. I think it's majorly about querying the data or creating tables, and you can go through different online resources as well. If you search about SQL, there are like maximum 20-25 things which you can easily learn about, and like it's an easy thing to do. The only thing is that usually in the at undergraduate levels, you don't need that, because you don't have that big database, right? The database on which you do projects, you do you do your research on are very small data sizes. Like here, I'm talking about data sizes which could be in terabytes, right? So or gigabytes, right? So that's where SQL is needed. There, SQL also there's something called Hive, which works similar to it's a querying language only, which works on distributed environments. Yeah, so when you're moving to industry, right, you have to handle that size of the data, and for that, understanding of SQL is must. And you should try to build those concepts because that would be asked mostly in your interview. Right, whether you know, that's the first thing usually asked in any data analyst or data science role, that whether you know SQL or not, and that is must. Okay. On the left side, I've put some of the packages which are readily available on Python that provides like that using which you can build various machine learning algorithms. Like for example, there's TensorFlow, there's scikit-learn, there's Keras, there is Pandas and NumPy is about how to handle the data. There's an NLTK, which is for natural language processing. So like each of the packages are known for different kind of algorithms. Like one of them is known for natural language, another is known for neural networks. So like you should be aware of these kind of packages and how can be used. Python provides, at least for TensorFlow and scikit-learn, which I've Pandas and NumPy, where there's very good documentation available online. You will find like what codes you need to use, what packages you need to use to build those kind of models, and they're very easy to use as compared to like it doesn't require you to know very hardcore programming. These packages have made it very easier to build ML models. Yeah, so anyone who is across any of these models packages, like anyone has used maybe scikit-learn or Pandas or TensorFlow? Yeah, Umar, Fadu. Yeah. Good. I think these are the things which you should try to use, and like if you use them in your final year project or any internship you do, I think that would be a good thing for your resume as well and for your understanding as well. Okay, so that's on the programming side. I think the second aspect was the maths and statistics, right? So is it? I feel like I've just copied the image, but largely it's not very clear. But what I would try to explain is that from statistics perspective, which is the one I feel the stats, someone who is doing undergraduation in statistics would be very strong in. But we should also know are the things around how to read the data, how to like statistically read the data and analyze it. So the usual problem is that what usually happens is when you try before building the model, right, you need to see the data, right, what it is, what distribution it holds, because that decides a lot, like what are you trying to that decides a lot, like what is the future course of action will take on the data. So and also when you for example build a model and then test it, right, there are various techniques to see whether your model is providing any incrementality in terms of efficiency you're trying to build in whatever the objective function is. So you like where there are various terms I feel like everyone should know. Like for example, confusion metrics. I think a lot of you would be knowing when you're validating a model, right? You use recall, precision, accuracy, F1 score, right? That's what the maths which goes behind when you're validating a model. And by validating a model, right, usually you train a model. I'm assuming most of you would know who have built any model, that you train a model and then you validate it on some data to see how it will do in the real world, right? And for that, you try to come up with confusion metrics and see what's the precision, accuracy, recall of that model is. Like I think we can have a separate session on these kind of topics as well. But just giving you an overview, like where is it being used. There's about hypothesis testing as well, right? So let's say if I have a if I have two cups, right? For example, I have two cups in my hand, and I say that one cup is bigger than the other. Or like, let's say if we see that we have two population and say the average age of the population or average age of the batch is 25 years, but there's one there's or 20 years, and there's someone who comes, no, it's 21 years or 22 years. So like, how can we like validate that hypothesis? Because currently it's just a hypothesis, and how can we see that whether it's actually true or not? For that, hypothesis testing is done, and I'm just trying to put it in layman's term because I feel most of you would not have used it, but it's used a lot when we are testing the models and seeing that whether, let's say, two results are different or not actually, or it's just the noise which is bringing that difference. So there are different ways to test that. Then there's distribution. There's the Z distribution. There's the Z test, T test as well. Central limit theorem. So these are all the things basically you should know from statistics perspective. Each of the line I have is like one chapter in a book which explains about it. Like you should be aware of what each of these things. At least I think it almost cover most of it. Let's say, for example, if someone know what the difference between census and a survey? Right. For example, the government of India do a census every 10 years, right? And then there are so many surveys as well. Like, what is the larger difference between a census and a survey?
Surveys are specific. Census are basically calculating the number and all.
Both calculate the numbers, right? Both have some objective, right? So the objective of, let's say, census is that they try to estimate try to figure out what the total population of India and what is the demographic.
Census is the data of individual ones.
What do you mean by individuals?
It means if I am being examined, then what is my knowledge? Just like किसी एक पर्सन का क्या क्या व्यू, मतलब क्या क्या उसके पास है, या जस्ट लाइक हम एक पर्सन को ले रहे हैं तो उसके पास कितनी प्रॉपर्टी है, कितनी नॉलेज है, तो इंडिविजुअल बेसिस पे उसका सेंसस निकाला जाता है. बट जो सर्वे होता है वो किसी पॉपुलेशन को ये करके किया जाता है, जस्ट लाइक किसी एक जिला का या सिटी का.
No, both of them are on population. So if you think about census, which Indian government does, right? It's estimating the population or coming of the population of whole the country, right? Whether it's 130 crore population or 140 crore population, and how many are males, how many are females, what age bucket what's the distribution based on age. So the difference is that when you do a census, right, you try to cover the whole population, right? For example, when census happened, there's a huge human resource investment goal where people go door to door and figure out how many people are staying there, right? And how many males and females. Survey, you would have known, right, when COVID was going on and there was seropositivity test which was coming. It was survey. You take a smaller population of the overall population, just figure out on that population only. So that is the difference between survey. That survey is just on a small sample, and then census is on the whole population. So that's a larger difference, and obviously the trade-off between the two is, one is very resource intensive, second is not so resource intensive, but the second one is prone to errors and the first one is more accurate. So not for everything you can do a census, right? Because let's say I'm trying to, a company is trying to do a survey, is trying to see what's the sentiment for that organization is outside, like what does customers of Amazon feels about Amazon, right? They're doing something. They cannot do census because they don't have those many resources. They cannot go to each and every customer and figure that out. So what they do, they figure out a small sample of the customers and send out a survey to them, a questionnaire, and try to figure out what the sentiment is. So that's the difference between census. So these kind of things you should know, that in like pretty clear concepts for each of the ones, like what is a normal distribution, what is a binomial, like these things were you would have got taught in your first and second year of applied mathematics, right? What is binomial distribution? What is Poisson distribution? I think so. These things you should know well in terms of maths and statistics, and these are frequently asked when you're like considering data analytics or data science role. Any questions? Yeah. Next is on the ML modeling side, right? Largely machine learning, if you think about, is of broadly three types. One is supervised learning, you would be knowing. Supervised learning can be classified into classification, regression, and there are various techniques in each of them. Then there is unsupervised learning, which is clustering and dimensionality reduction. There is reinforcement learning, where it tries to like there's a feedback loop, and it tries to correct the model tries to correct itself in an automated way. So then, like, you should know what all different kind of models sit in each of the buckets and how do they work broadly. Like how does let's say there's a clustering technique, right? How does it work? What is the at an overall level? What is the maths behind it? There's boosting technique for a classification algorithm like gradient boosting machine. There's classification algorithm called support vector machine. So those kind of algorithms you should know well that how do they work, and what is where basically you should have an idea that in what kind of use cases what kind of model can be used, for what kind of problems to be solved, what kind of an ML model is to be used. So that will show that you are already aware of this subject. You have already understood it, and you know what each of the model is used for. And the second thing is like what is usually a building, like what steps you have to go through when you're building a model, right? You define the problem what you're trying to solve for to build the model, and then you come up with the data, what all data can be used to predict or to solve for that problem. You clean and prepare the data, you do flooring and capping, you do missing value imputation and all. You analyze that data and see what are the insights to figure out what all features you can come up with, which can be powerful for you to predict. And then you train the model, you validate the model, and then you deploy it into production. And also you try to give this whole process is done iteratively so that you optimize for the model performance, and you set the parameters for that model in a way that it runs at a good efficiency. So yeah, so like I feel like if someone would have built a model, they would be across these steps. Anyone who has built an ML model can share their experiences and whether they have gone through these steps or not. Anyone in the final year of engineering is someone there who might be working on the final year project and ML they're trying to solve using ML model.
Can I step in, Sayesa?
Yeah, sure.
Well, I'd just like to say to the students, that if the speaker wants it to be an interactive session, it's really good. It's outstanding, and you can have, as you move forward, you can discuss issues. So it'd be great if, students come up and really have some questions answered, possibly, Why he's asking is that obviously, through your experience, he could guide you a bit more and sort of, things would come up. So it's always good to have presentation, but it's the best to have an interactive session, which obviously, the speaker is very happy to entertain. So I would say that come up and ask those questions there.
Excuse me, sir, I had a question.
Yes.
Sometimes when we in YouTube recommendation, when we don't recommend this channel, so this comes under reinforcement learning, because we are giving YouTube the data that we don't want to see this channel, and then it is not showing this. Is it correct?
I think that depends on kind of like you should say usually these recommendation engine works on the premise of on the base of collaborative filtering largely. That there's a technique called as collaborative filtering, in which what they do is that, for example, I have watched these things, and people like me who have watched these things also watch, maybe if you have watched ABC, that then people like me who have watched ABC also watch D, and that recommends it. And then if you send a feedback that you don't want to watch that, I think it goes into the as a feedback, uh, and try to correct for it, that this is not the area of interest for you. Your profile or your persona is different as compared to what the usual population is looking at. But it also, I might not be aware on what is the backend looking like, but surely there will be a feedback loop. Not sure if it's through reinforcement learning. That someone who has built that model can only tell, but largely there would be some feedback loop that would be correcting that recommendation. That okay, this is the person. This person's profile doesn't match with like preferences don't have that match, and they prefer to see something else. So largely, yeah. If I have to answer your question, there is a feedback loop, but what technique is being used in the feedback? It could be a simple rule as well, right? If someone says no on this kind of recommendation, we'll not show that recommendation. Right? It might not be an ML model at the back end, but there can be a case where it can be reinforced as a feedback loop as well. Yeah. But reinforcement learning, I think I can tell you where it's being used a lot. Has anyone heard about AlphaGo? DeepMind, and basically, so Google has come up with uh, this platform or this AlphaGo, which basically tries to train for different board games like chess. So chess is a very so what it does, it's real time, on a real time basis. It keeps on training itself and tries to optimize for its moves so that it wins. And AlphaGo is known for for coming up with uh, advanced solutions or machine learning based algorithms for playing these board games. So they play with grandmasters of the chess, and they defeat the grandmaster of the chess using these kind of models, which is reinforcement learning. Yeah. I think Umar was asking something.
No, sir, I was saying that I have trained some ML models and
Okay.
have used some of the techniques that you mentioned in the pipeline.
Okay, got it. Got it. Cool. So, coming to the last aspect, which is on business acumen, right? Domain knowledge, which was the third Venn diagram in the first few slides, the third circle in the Venn diagram. So, so when there's an interview going on, right? They try to assess how strong are you in the like business acumen, which includes your ability to understand the business. For example, if I'm interviewing for Amazon, right, I should know what Amazon does well, right? What is their business model? How do they earn revenue? What are the different features they have on the website? What are their different strategies? So understanding of how a decision you make using as a data scientist might impact the business, right? That's what the objective is. And how well do you think in terms of business aspects? That is very important to know. Then second is you should have good understanding of data. Your intuition should be very strong. Then your communication skills should be good, that you're able to communicate what you're trying to do. And there's something called critical thinking, that when you say something, you think through that whether it passes all the tests, and you have thought through well that there are no loopholes in it. So so that you don't end up in a stage where the solution is not right. So those kind of things they try to test. Like for example, for business acumen, they try to give you situations based on different business problems which a company might be facing, and how you'll solve for using as a data scientist or data analyst. And for understanding whether how good are you in terms of data and intuition and critical thinking and all those things, they give you puzzles, they give you guess estimates. Does anyone know what guess estimate is? Okay. So basically, guess estimate is like, let's say if I have to estimate in this jar of bottle, how many balls are there, how many candies are there, right? So without opening the jar, you have to figure out how many candies are there, right? So you should have a thinking process or logical. You should logically come up with a way that you can estimate it accurately without counting them individually, right? So you can use maths. Okay, you if you know, let's say this is the volume of the bottle, and the volume of each ball is X, and if it is filling by this much percent, then how many? So that kind of way, if you can figure out what are the number of candies in that bottle without opening the jar, that shows you that you can think well, you have good understanding of data, like you can estimate things well. Because let's say if I'm in a company and I'm sitting in a meeting, and all of a sudden someone asks me like, what do you think, how much would be the savings from this machine learning model which you're one way is I go back and come up with an accurate estimate, but then and there itself, if I have to tell a number, I should be able to calculate that quickly and tell it to the leadership, right? That's what has been expected, and that's where strong understanding, so strong intuition, critical thinking, and all those things matter. Okay. Yeah, I think largely, if you have to build your resume right, I've just put down 4 or 5 things. Try to do as many internships related to this field in your second, third, fourth year summers break. Try to pick a topic in your final year as a project work, so that matches to what you are, that matches to this field. Thirdly, you can pick those courses if offered in your curriculum to gain knowledge about these things. Like I remember artificial intelligence we used to be an open elective even when I was in my engineering, but I feel like the curriculum would have changed a lot now. It's been 10 years now, more than 10 years. So those kind of things you should know. There are various certifications which you can do externally to through Coursera, through other online sources which can help you quite understand on these topics. You can also, if you're doing a project, right, you can write a research paper and get it published somewhere or present it somewhere, so that's an added value on the resume. So if you have those kind of points on your resume, it's easier to be like, so because any role, if this gets open, there's so many applications, and then there's a shortlisting process, right? If these things you have, it's easy to get shortlisted, and then you can get a chance to get your first interaction done, first round of interview, and it just then matters how well you do your interview, right? So the resume, why resume matters is you reach that first round of stage, and then everything else is basically how well you do in the interview. So so to make sure that your resume has those kind of eye-catching points which make you through the screening round, and then you at least reach the first round of interview.
Hello.
Hello.
You can't be like good in all of them. So which do you think? Which point should we emphasize on our resume? You can't be good in all of them.
Yeah, like if you can do all of them, it's good. But I think, but I think that requires a lot of planning and
I'm in first year, so I'm just trying to get an idea of it.
Yes. If you're in first year, you have a lot of time. I can pretty confidently say that you have a lot of time that you can have all of them by end of year. I'm just thinking like for those who are already in fourth year, they can maybe if they can do their project work related to that. Yeah, maybe they can do some certifications. They can do research papers, right? But for those who are in first year, they can pick internships like that, right? Because you are just starting your engineering, and there's a long way ahead. You can cover all those 5 points and easily have those on your resume, because 4 years is a long enough time period to have 5 points on your resume, right? 1 year each, you can have 1 point. So that's doable. But if someone is in final year, they can gauge for themselves that if they want to continue in this field, what in next 1 year they need to do, so that by the time in June or May they pass out. Like even for the final year ones, right? They can go and do masters in these kind of courses. I'll come to where the masters, which are the good institutes where you can do masters as well. But like it's not the end of, like if you are really excited about this field, right? It depends. You could be excited about your core branch as well. I'm not forcing anyone, but if you have that intent, you want to pursue your career in this direction, then like these are things you can have.
Thanks.
Yeah, I've just listed down some of the online sources, some good Coursera, Coursera courses, and then like which provide good, which will give you a good understanding what these topics are about. There are some online competitions which happen on Kaggle, right? Kaggle is known for that. Has anyone played any competition on Kaggle? Has anyone used Kaggle ever? Okay, I think Omar has done everything. So yeah, Kaggle is basically I would say a website. You can just Google Kaggle and find it. They host various online competition related to data science and and there's actually a prize money to be won as well a lot of time if you rank as the winner, right? So try to go, if not participating in those, try to see how the winners are creating solutions for those. That also you can find it. So that's a good thing. And I think there's an Indian version of that as well, Analytics Vidya, which also organize some of the competition. In fact, right, different companies organize competitions on Analytics Vidya, and if you win, they provide you interview chance as well. So try to explore these kind of online portals so that it opens door for other things as well. Lastly, like some of the courses, I think if you have plans to go abroad, right? MIT have a Master of Business Analytics. Like these all big universities have specific programs just for business analytics and data science. You can also go through computer engineering route also, right? You can go for masters in computer engineering and pick your research area in machine learning and all, and that will give you a good career in that domain. Within India, like I feel like there are various institutes that have come up with these courses, but I feel there's one course which is being running for last 6-7 years. I feel it's using it's through a joint initiative by IIT Kharagpur, IIM Calcutta, and Indian Statistical Institute. It's called Postgraduate Diploma in Business Analytics. It's a very good 2-year course, and I think that's one of the best in India if you want to do pursue a career in this domain. I think the placements are very good. I think the seats are very limited. What I remember, 60 or 100 seats only. But what they do is that it's a 2-year course, 6 months each you spend in each of the institutes, which is IIT Kharagpur, IIM Calcutta, Indian Statistical Institute. So that's 18 months. And then last 6 months is an internship, which you do. From there, you usually get a pre-placement offer. So I think this is the best in India as of now. But I think there are various other colleges and institutes which have started. But if I have to recommend, if you want to do postgraduate in business analytics, I think few of the MU folks have done it in last 4 or 5 years. I've been in touch with those people. And yeah, this is a good one. I think I'm already over time and I've ended my presentation. Any questions?
Sir, I have got some questions from some other people who texted me last night. That some people are busy in mid-sem examination right now, so they're not able to join the sessions. So some people were asking, like, is master needed as mandatory things? Because some people are confused about if I'm going for a data scientist job and something like that. Is master is necessary or not? And how you see the people in your working with you?
So it depends. so it depends from one thing. It depends from organization to company as well, right? So, for example, when I was at MX, they usually 80% or 90% of the folks were masters, either MBA or masters in on the technology side. That was the case. There were few folks who were just fresh out of undergraduate from these, usually from IIT, that they used to hire. Amazon, I've seen fresh graduates who have who they take people fresh out of colleges. Uh, I think master's is not mandatory for data science role. Even for Google, I think fresh out of colleges work. It's just that you should have that strong profile that it gets screened through and you get a interview shot. But I think if you want to do a master's, there's no problem. I always encourage people to do masters in whatever domain they want to, so that they're.
So doing masters in MBA would be better, or going for a data analytics part particularly, or going for some core masters in artificial intelligence or something like that. Which one would be better, in your opinion?
So yeah, if you have to if you want to go into core these big tech companies like Google, Amazon, Facebook, and all, right? If you go into the core specialization, masters in technology or masters in science, that is better because that is where they hire from. Because I went through a financial services route and then ended in Amazon, right? These financial services usually hire MBAs as well. So that's how I got in there. But if I would have tried at that time to get in Amazon or Google, it was no way possible. So I would suggest, if you want to pursue a career in this domain only, specialization in this domain through MS or MTech is better as compared, and getting a job in this domain is easier as compared to through MBA.
Thank you, sir. Also, Abid Hassan has asked that what made you switch from the core engineering to data science. Also, I would like to add something else. Something in this question is some people also asked me from he's from MTech. I guess Narayb Kamar Bhai is here or not. He asked me to ask you questions about that because we are already recording this session, so with some people will get benefited from that also. That some people want to switch their field after working like a teacher or working like even surgeon, even in medical background, people coming from core engineering, civil engineering, and they want to switch as a data scientist. So how tough it is, and what are those barriers, and what are those parameters that you think that should be covered to do that?
Yeah. So I think what I've learned. So if you see these business analytics course, for example, I'm not sure what is the usual eligibility for those. For someone who might have been who's not was not done engineering or is not done like undergraduate in statistics, and maybe in some other domain want to switch, they can always go for a postgraduate program and then make entry into this domain. That's one thing. To be frank, like it would need a very strong reason for that, because you have to go through interviews in those. For example, if I'm not sure whether I feel like the course which I mentioned, right, IIT, IIM, IIM, I think they should, the eligibility would not be that only the engineering folks can apply. I think everyone can apply. I haven't read that through, but mostly it would be the case. And if you crack that competition and you through the interview round, you will be part of the same batch, and you can get a job in this. So it's just about cracking those kind of competitions. Like without post graduation, I feel it will be tougher, because usually they prefer core engineering or computer engineering folks, or at least engineering you have done with an intent, with past history of points on the resume that you have done some work in this domain. I think that's how usually the recruitment happens for these kind of folks.
Okay, sir. Thank you, sir. Also, Muhammad Haris has asked questions. I'm in from the library science PhD student in the chat box. I'm working on a recommender system. I'm not from the computing background. How to start? How do I start working to achieve my project and something like that?
So what recommender system is he working on? Harish, can you explain?
Harish, are you here?
Like, what is the objective of this recommender system?
Yes, sir. Assalamualaikum. I'm working on recommender system for digital libraries.
So what do you recommend as part of this? What will you
Generally,
recommend?
libraries had databases for articles and books. I I make a recommender system for recommend books and articles, research articles,
Got it.
etc.
Got it. So yeah. So I think I think usually, as I said, I think during the course of the presentation as well, largely the recommender systems which are built are based on collaborative filtering. You can read about it. Have you read about this collaborative filtering?
Yes, yes, yes.
Yeah. So I think if you have already read about that, then you are on the right path. I think that is what is used mostly, and it would be a good algorithm to build a recommendation system for library science as well. I guess you would be recommending, for example, if I read XYZ kind of books, then you will be recommending ABC kind of books to me because those are similar types. So if that's the intent, that's the problem you're trying to solve for, I think recommender systems based on collaborative filtering work well there. Yeah, I think Saqib is asking, is there any kind of internship in these fields? Yeah, I think most of these tech companies and even all the startups have you can do internship. I think what you need to do is that, like, before applying to those internships, you should have some experience or some understanding on these topics, and that should be reflected in your resume so that when you apply, it gets screened. That is must. And secondly, I think I feel LinkedIn is a good source to get these kind of internship nowadays. And I said one more thing was these companies organize different competitions online. Participate in those kind of competitions, try to win it, and you will get a chance to do internship. You will get a chance to get a job offer there. So those are the different routes through which you can get an experience of this domain. How much time it takes to learn if I am from different backgrounds? Like, if you can be more specific, which background are you from? Like, is it within engineering? If you're from electrical or electronics or mechanical, it's a different answer. If you are like doing medical science, then it's a different answer. Yeah.
Muhammad Anis, are you here in the meeting?
Yeah, I think he's from electrical. I think for electrical engineering folks, I think I think a lot of projects I know which are being done in electrical engineering department, they're trying to solve for problems using machine learning. I think there was someone who was working on support vector machine. So you can pick those kind of projects as part of your project work or research, and gain expertise in this domain, and that would be a good way to learn about it. And I feel like you can take open electives also if there are any around. I think there's around one around artificial intelligence. If there are others which are new, which you can take and get familiarized with these topics, that would be helpful for you. But yeah, how much time, I think it depends on how much effort you are putting in. It can be done in a year also. It can be done in 2-3 years. Like, it's an ongoing process. Yeah, I think if you're referring to certifications, I said right. The idea should not be that it would be on your resume, but you should know you should go through that certification thoroughly. You should, after that certification, it should be the case that you have come out learning something, and that should be the objective. If you are able to do that, I think that would be good for you, because you will have that domain knowledge, and then you can use it anywhere you want.
One more last question. What was your some good moment in Aligarh Muslim University when you was there in Aligarh? Would you like to share that?
Yeah, so I'm born and brought up in Aligarh. I did my schooling from St. Fidelis and I did my 12th from there, and then I joined AMU. And I, I it was a great experience, 4 years. I think one of the best moments of my life. Yeah, I always miss those 4 years. I feel like you guys are there, try to maximize on the time you are having on the campus. Maybe not on the campuses of now, but yeah, try to make use of things. Try to make friends. Try to make strong networks, and yeah, try to study hard, right? Because that's very important. Like if I remember, like when I was in first year, people used to say CPI doesn't matter, and I would just say that's not right. It does matter. Like if I have to uh, look back and see what those people were saying, that's not true. CPI does matter. Work hard, but be active in extracurriculars. Be an all-rounder. Uh, Play sports. Be part of national university team or college team, whatever it is. So do everything, but yeah, study should always be a priority. And yeah. Banking and financial analytics major from where? Which does AMU provide that specialization? Shakir is asking that question. Jamia. Okay. So as I said, the programming language is necessary even if for a data analyst. But if you know you know SQL well, that is must. I think maybe if you are just not if you're not that good in Python, that is fine. But SQL is must for a data analyst. I think, and it's a very easy thing to learn as compared to any other languages. Okay. Anything else? Any questions? Feel free to reach out to me as well. I think you can. I'm on LinkedIn. You can drop me a note and I will try to reply. And yeah, happy to guide anyone. And I'm happy to take more sessions if needed in future. If there's specific ask on any of the topics. Yeah.
Ifra, are you here?
Yeah. Thank you so much, sir, for this amazing session and also for sharing your experience of Aligarh Muslim University and Aligarh as well. So, thank you for taking out your time. Lastly, without taking any more of your time, I would like to call Ms. Javeria Sajid to give the vote of thanks.
Hello and Assalamu alaikum everyone. This is Javeria Sajid, serving as the Joint Secretary of IEEE Student Branch AMU. I am truly honored to deliver the vote of thanks for this amazing session on the behalf of our whole branch. First of all, I would like to thank Mr. Safdar Kazim Haider sir for sparing his valuable time and enlightening us with his thoughts and experiences. The tips and advices from today's session will surely help us in the long run. I hope you had a great time here with us, sir. With your knowledge and guidance, I hope we will be connected in the future too. Sir, this is a virtual memento from our side. Please accept this small token of appreciation on the behalf of our team. Thank you so much again, sir, for coming today. And I would like to also thank TPO ZHCT, Mr. Farhan Saeed, sir, for joining today. I would also like to thank Mr. Mohammad Zaid, sir, our branch counselor, Dr. Tariq, sir, and Dr. Rihan, sir, our branch coordinators, for their constant support and guidance. I would also like to thank our patient and sincere audience for joining us today. I hope you guys have gained a lot from this session. And lastly, a big shout out to the IEEE Student Branch AMU for conducting such great sessions. Thank you everyone for joining.
Thanks, guys. Thanks.